Hello everybody, welcome to Unity 2D Brick Breaker game. In this video you'll be learning how to create a brick breaker type game that will bounce off these bricks. And if you destroy all the bricks you will win the game. You'll see that you can hit them at a little bit different angles and it'll move the ball around. And if you don't destroy all the bricks you lose the game. And if you destroy all the bricks, you win the game. Okay, so the first thing we're going to do is I like to drag in this just a white block so we can manipulate and change the size and shape of the background really easily. And so we'll start off by scaling this background to quite a bit larger, closer to what we're looking at. So we kind of center this a little bit. We can set these to 0, 0, and then we can change the color. Change color to black. So if you go into game and then you're able to choose away from free aspect ratio, and so I'm going to go a 3x2 here. Okay, and then we can rename this background. And we can have this order be -1, so it's behind everything as the background. And we can drag in our walls. And we can make these. We can scale it by using the rectangle tool as well. And size it that way. Make their X 1. And then we can make another wall. And we'll put this one in the middle and leave our X at 1. Excuse me, leave our Y at 1 this time, but then stretch it out so it's all the way across here. Then we can just duplicate this one and use the move tool, slide it over. There we go. Scoot this one over just a fraction of a bit. And that's good enough for what we're trying to do here. Okay, let's change these to a different color. Make it look a little bit nicer than just white. There we go. And then we can rename these walls. So I'm going to create a new game object. Create an empty game object that all of these can be put beneath. Hold control, click on those 3, drag them underneath, and then now we can have all of them together right there. So now we can highlight all of them and we can add a box collider 2D and add a rigid body 2D. Make sure the 2Ds are on each of these so it actually works in your game. Then we're going to go ahead and create our paddle. So I'm going to drag in another white block and I'm going to scale it quite a bit wider. However wide you want to design yours is fine. This will not change any of the physics or anything like that. I'm going to go ahead and give it a bright yellow color here for our paddle and try to start it off lined up at 0, and then will the Y value be 4. That way it's right on the line here, right in the middle. We're going to go ahead and give this a rigid body 2D, a box collider 2D, and if you zoom in, if you edit this, you can really see how it lines up perfectly around where you want your box collider to be. And we're going to rename this our paddle. Now there's more than one way to add in an asset. Here we've just had a white block in the past, but if we just create a game object and then we add a sprite renderer, that is a way to render a sprite image. And if you click this plus, you could put white block in since we've already uploaded it to our project folder. You could also make a background and some other things, but we want to do a knob. And we'll have our knob be whatever color you want the ball to be. We can have it be red, and we want to resize it so we can actually see it. Let's have it go ahead and be 2, 2. Scale wise, start at 0, 0. If we look in our game, we can see and check that this is the right size. Okay, and so now that we have our ball, we want to rename it to our ball. We want the paddle to be able to move, we want to have the ball be able to move, and we want to build our blocks here. So let's go ahead and start scripting a little bit. And so we can right click, create a new folder for our scripts, create a new folder for our assets, and create a new folder for our prefabs. Always a good idea, but the bigger the game, the more important this is to actually do. Some of these smaller games, it's really not necessary, but it does keep you organized. So now I'm in scripts, and I'm going to create a new C# script, and we're going to talk about the paddle. And so we can open up our Visual Studio. So the first thing I want to show you is how to program the paddle to move along with your mouse. And so we would do this dot transform dot position equals new vector 3. And we're going to have this vector 3 check the input of our mouse position dot x, and then nothing to the y and the z value, and Control S. Let's put our paddle code in our paddle. And before we go any further, we want to make sure that our walls have constraints, so they're stuck. And our paddle is frozen on the y value and the z value. Okay, now this is not going to work exactly how we want it to, but if we go back and run it, you can see if you put your paddle or put your mouse right by where it's 0 for the camera, it will bounce back and forth for us and do somewhat what we want it to do, but not centered correctly. So in order to center it correctly, we need to reference the camera's location, and the camera's x value, not the world's x value. We need to specify the camera. And so in order to do that, we can do public camera and give a name for our main camera. And we can set this main camera, and we can set this to find object of type right there. And what is the type of type camera? Open close parentheses, and that will find the object camera in our world and set main camera to it. And we need main camera we need to be referencing the x position of our main camera. So in here we need to say main camera dot, and it's going to be a screen to world point, and that will say get the x value of my mouse position in relation to the camera. The screen to world point needs to be a new vector 3 as well. And so inside of this new vector 3, we're going to get the x value of the mouse position in relation to the point of the main camera. So dot x, comma, so let's get our parentheses 1, 2, 3. We should have 1, 2 here, comma 0, comma 0, close parentheses, semicolon. Show a little bit more room here. You can see main camera screen to world point. If you click on this here, it'll say transforms a point from screen space into world space, where world space is defined as coordinate system at the very top of your game's hierarchy. So gets the main camera's screen point and converts the mouse position of X of your main camera, so that your main camera can see where your mouse is on the main camera in the X position here. So this is all your X value here, and then nothing to your Y or your Z. But our Y value actually should probably be a little bit negative, -4 maybe. We save that, run, and then you can see our paddle moves. Okay, now we need to have parameters for it so it can't go all the way off the screen. So if we have those numbers, we click on our paddle, we click back into the world, our paddle can get up to about 5.8, let's say 575, and -575. Okay, even if that overlaps a little bit, it allows for an edge here. So we should make a variable here that says float left max and float right max, and those can equal -5.75 f equals +5.75 f. So in order to put a left and right max, we need to clamp this. So we're going to create a variable that's going to be called max movement. Math f.clamp, and what this clamp does, clamp gives the value between given minimum, maximum float values. So here is our value. This is the minimum it can be. This is the maximum it can be. Okay, so float clamp, the value we're going to get, and then our minimum is going to be a left max, and then a right max will be our maximum value. Now we need a variable to plug in here that's more proper than just trying to plug in a new vector3 input mouse.x. So we will do input dot mouse position dot x for right there. And so here is the max our x value can be for the movement there. Now, but we need to get the relation between the camera and the max movement. This will give us our max, but it still won't be good enough to refer it to the camera. So what I want you to do now is I'm going to copy this second half, and I'm going to actually cut this and turn it into my own variable for our world X position. And so this will find the main camera, and it'll give our X position for our mouse. So then we get rid of this, because this is just an X position. This is not a new vector. And then we need to actually transform along a new vector. And so the new vector, well, our X value will be our world X position. Our Y value will be -4, and our Z value will be 0. So after some testing, your left should be 70 and your right should be about 530. And that will let you go edge to edge without having any really overlap at all. And so now we want to add in our ball. Having this all in the update method is really not good practice, so we can go void movement, and we can cut this, put it in the movement method, and have our movement go right there. Okay, then save, and then we can add in a script for ball. Create new C# script, ball. We can drag this into our ball. Now what we're going to try to do is have the ball actually, instead of just being made pre-game, go ahead and have it follow the center of the paddle. And so we need to have it so that the ball gets built in at the beginning of the game, really before you do anything with the game, and then you click in order for that to be initiated and the game to start. And so we're going to need a way to manage our game, and so we're going to create a C# script called Game Manager. And we can go ahead and open that C# script, and you can see Game Manager is already a pre-saved C# script with the icon, but it basically does the same thing. So the first thing we're going to find is a public ball. We're going to call it ball, and this is the way we can reference our initial ball. And then we can do public ball as a prefab as well. And so we need to initialize a ball, but we need to have a reference to the ball prefab as well. Okay, so once we have that and save it, we need to go in and actually create an empty game object, and we're going to call it the Game Manager. And this way we have something that we can drag our script onto that will be invisible essentially in our world, and we'll be asked for the ball prefab. Okay, and so our ball starts there, but we want our ball prefab to be drug in to our Game Manager, but first we need to create a prefab. So in order to do that, you got to create and drag it in, and this will create a prefab for it. You notice the ball turns blue, and for now we'll leave it in our game, and we'll also create a prefab for it. And so now it knows what to copy in order to create the initial ball. And so this actually will make it so that we can delete our prefab, and now in our game right now, before we put the script in, ball does not show up, but we'll get it to show up now. And we want the ball to show up in relation and reference to our paddle. So we're going to need to have our paddle be able to be found. And so in our void initialize ball method, we will create a location, a vector 3, for our paddle position, and we will set it equal to paddle dot game object, reference the paddles object. So here we have a reference to the paddle class, but we want to reference the specific game object and their transform dot position they are at. Okay, so now that we have that vector 3, we can use it to place the location of the new ball. So we need to create a second vector 3 that will be our ball position. So that'll be equal to similar spot as the paddle position. So it'll be a new vector 3, and we're going to do paddle position dot x, paddle position dot y, but we're going to add, and so it's just a bit above, plus 2.5 f, and then the z value can be 0. And now we have a value for our ball position, and so now we need to actually initialize the ball prefab and make a clone. So we'll say initial ball equals an instantiation, so instantiate the ball, the prefab, should be more specific with that, the ball prefab so that's the object that you need to instantiate, and then it needs also the transformation or the location, so that would be the ball position we just created, and then you can create a quaternion dot identity, giving it the same rotation that it already has. Really, rotation is not much of a factor in this game. At our update, we need to initialize ball our game manager needs to have a ball prefab. So we have our prefab, drag in ball. Our paddle should be able to be referenced as well. So we drag in our paddle that's already in there. And then we run it. And you'll see a bunch of different balls that pop up. Okay, and we can make a whole bunch of them. Don't crash your computer with that because you'll be making a whole bunch. Okay, so what we don't want to do is have it constantly in the update method. So we need to have a way to start our game. So in order to do that, we can do a public boolean start game. So we'll initialize the ball just at the beginning so that we only have one ball getting added in. Now the problem with that is if we run it, we have a ball to start, but the ball doesn't move along with us. Okay, so it starts at the correct position, but we want it to continue on. So I'm actually going to move these and copy and paste them so that they are constantly getting reset in our update method. If start game is false, so we haven't clicked to start the game, we will have initial ball dot transform dot position equal to our ball position. Okay, then if we save that, and we're going to need a way to change it from start to not start, we run it, and the ball will follow because we haven't made start game, which is in our game manager. Start game is false. If we changed it to true, and then we click back in, it won't move anymore. Okay, and when it's false, it will. Okay, if input dot get mouse button down and have it be 0, we can have start game equal true. So then when the game is started, it'll stop moving. So now we need to have the ball do something once start game is going. Okay, so we need to go back in and go back to our scripts, go to our ball script, open it up. So I'm actually going to have our start game be static because there's only one time or one instance of the start game, and that'll either be started or not started. And then so that way we can say, once we create our void movement, we can say if game manager dot start game equals true, we will have our ball start having a force applied to it. And so we need to do public rigid body 2D RB, and that will be the name of our rigid body. We can do rb.add force. So as you can see, we're going to add a force, and that needs to be a direction. So if we do transform.up times 5, that will apply a rigid body force. So if we go back in and go to our ball and add a circle collider 2D, we can double click on our ball, we can edit the collider, and then double click on our ball prefab, and then make sure that that lines up just perfect. And then we can go into our ball and add a rigid body 2D. And then our rigid body 2D, you can see, has gravity, scale, mass, all these different things. We're going to have our gravity be 0. And we're not going to freeze anything right now. We're going to have it move around. But we're going to that's how we can go in and edit our force and transform it up based off our rigid body. So we look at our ball script, and our ball class expects a rigid body. Well, the rigid body is going to be the body of our ball. Just add that to the RB value. Okay, and then you move your movement into the update method. Make sure you save, Control S. you can see that the force gets faster and faster, and it continues to use that force. So we need a way to not only when the game is started, because it's true and it keeps happening in a repeated fashion, but we want it to also have a way, and I'm going to do game manager dot game started and make that have to equal false. And then after we add this in, we make game manager dot game started equal to false, so that this only happens one time. Game started is not in here, so we're going to do a copy, and instead of start game, we're going to call it game started. So after the game's been started, and this force will happen and be applied one time. Now you need to increase this force by quite a bit. I'm going to do 250. F should be a float, and that will only happen one time as opposed to the 5 that was happening over and over again. And do Control S to make sure you save. That way, when you click, you need to have your ball. Game started should equal true, not false here. So that'll make it only happen one time because it still was going too fast. So you need to make sure that it happens one time. I messed up there, and there you go. Now you have a consistent speed right there, and just one force that is applied to it. And we could even raise that a little bit more to about 500. Just so we can really get it going. And then we need to have these be able to bounce, have the ball be able to bounce off. So you can go to your assets folder, and you can create a folder that will be your physics. So these physics materials, you're going to create a physics material 2D, and your bounce is going to go from 0 to 1, and your friction is going to go to 0. And basically everything besides the game manager, your paddle, rigid body should have a physics material for your paddle. For your walls, your individual walls, drag in the physics material right here, and that should do it. And your ball, so make sure you get that on your ball prefab. But there we go. Now we have a ball bouncing back and forth. And if you open up your ball class, when we click to start the game, we don't want to just have a rigid body force for our up and down, but we can go ahead and make it dot right and go ahead and do 250, negative 250 here, so we get a little bit of a bounce to it. So then we can see that we have our ball starting to bounce back and forth a little bit here for us. So now that we have those, we can create some white blocks. We can create our bricks. So we create an empty game object and we call it bricks. Okay, so when you add in a game object, it'll go in wherever it kind of clicks in. So if you go and reset this, then we drag in our white blocks and reference them to our brick. That means when we reset this, it'll be at this 0, 0, so that'll make it nice and even for us. So if we drag this over, it goes from about -7 to 7. So we can use that to know how much space we want to give it. So we can go about 6, and it'll be to 6, so that'll be 12 total units. And so if we want 6 columns, we would want to scale this to about 2 units wide. So this would be 1 unit, and if we scaled it wider, we would want it to be short of that, but we could scale it to right about 2 units fully wide, but we want some space in there. So if we made it about 7, scaled it from its original size to about 7, that looks pretty good. Okay, so now that we have our size, we can create a prefab for our white block. And this way, if I duplicate this, hold Control down, move it over, can hold Control down, Control D, and I keep making these duplicates, I don't have to highlight all of them to make a change. You can simply click on this, and if I wanted to click in and I wanted to maybe make it a little wider, you could go in and then go back and they're all quite a bit wider, okay? But now I'm going to go back in and make their Y value just 1. Okay, now we have our 6 prefabs here, and I'm going to duplicate them and move them down a row. And I kind of like their, looks like, as long as you hold Control down, it looks like 1.5 units down. So from, if we highlight all these and actually just make them 4, make sure they're lined up, then we can Control D. So they're all 4, Control D to copy them, duplicate, move them down to 3.5, move them down to 3, and go 2 units at a time. You can go 3 if you want, and decide how many rows you want to have. Now if we wanted to change our white block, we could change it up. And then all of a sudden you have a much more colorful little game to start. And you don't have to highlight all of them and to change them. You can just click on the prefab. We can make a box collider, which we'll need. Box collider 2D, a rigid body 2D. These will have constraints. There they are. Freeze the X and Y and the Z value for these boxes. The box collider usually matches up its collider really, really well, so I'm not even going to check on that. So we can run it, and our ball can bounce off, but they're not bouncy, as you can see. So we need to go into our prefab, add our physics new material, and our rigid body. There we go. Now, it's a lot bouncier. And your ball might get stuck if we can't remove them, something like that. So let's go ahead and start removing them. Void on collision enter 2D, and we'll say if collision dot game object dot tag equals block. We'll start destroy collision dot game object. Okay, so if it intersects with something that's called tag, it'll destroy what it intersects. Okay, so we need to make sure we tag our blocks. Now that we have this in here, so we can go back to the prefab. Let's zip this up. Go back to the prefab, our white block, and we need to make sure we create a add tag block, and then we need to tag this as block, Control S. Then when we run our game, our ball will read these as blocks, and there you have it. So in this format where we're at, there are times when the ball will get stuck and it'll bounce back and forth. What we want to do is find a way to minimize that and not let that happen. And so what we can do in our code is have a few if statements that help our movement and move you out of stuck spots. So we're going to say if our rb.velocity of our x value is less than 1 and rb.velocity.x is greater than or equal to 0, then we want to rb.add force transform.right. So if our x value is pushing a little bit off to the right, or it's not moving at all, we are going to actually push it right times negative 50. And make sure this is transform. And then if it's positive 50, excuse me, if it's greater than negative 1, and less than or equal to 0, that means it's between negative 1 and 0, and we want to push it to the right 50. That means it's barely moving left or not moving left at all, and we just want to bounce it off the wall. Okay, and so we also want to do that with our y value. So we will copy, paste, change these values to y, and this will be up and up. And let's see if y is moving down. Oh, and change this to y as well, and y as well here. This would have it move up, be moving up slightly or none at all. Then it will move down, which is what we want. We want it to, if it's stuck, barely going towards moving up, maybe barely grazing the top of the wall, we want it to bounce off. We don't want it to continuously be stuck. You can also create a, instead of a box collider here, you could remove it and do a capsule collider. And even if it kind of looks more like a box collider, we can edit the capsule collider of the actual prefab here. And if we edit it, we can change the direction to horizontal. And then now you can see that it has a circular edge to it. Sometimes that makes the bouncing a little bit more random, a little bit more fun to deal with. So you don't have kind of more, you see how it bounces a little bit more sideways, a little bit more popping up and down and changing things up for you. And you saw it right there again, and right there. Okay, so one change you might want to make is that if, let's say we got rid of this and we had it go straight up and down right at the beginning and there's no push off to the right or left, our x value is checking if the velocity is greater than or equal to 0 or less than or equal to 0 here, and so they counteract each other. So one of these you just need to make just less than 0 or just greater than 0, and then same thing with the y value. This way, if they're exactly at 0, which is what I'm going to start us off at, you will see that if I didn't have that, it would go straight up and down. But now that I have that, our velocity of our ball starts off at -1, but if I click it in, our x is negative, and it will never go to that 0 that we don't want to see. So let's start it at 250 instead. But now it'll never get stuck. Okay, so now we're going to check when all the blocks have been destroyed, and it'll have a you win screen, and then we're going to set something up for a you lose screen. So actually first I'm going to create the you lose object really quick. So if you hit this, you will lose, and we can change this to black, and we can have this as lose box, and actually tag it the same way. Add tag lose box, and then we will set this tag to lose box. Okay, now if our ball game object dot tag equals lose box, destroy game object this dot game object. Okay, we'll start off with that just so it doesn't go on forever. And in our game manager, we're going to have a public text, and we're going to set up a text that will be the end screen. And we need to find all the boxes, all the blocks that are in our code. And so we can do game object and create an array of all the blocks. Okay, and so this is just an empty array of all the blocks, and now we need to set this array up to blocks equal game object class dot find game objects with tag, and the tag we're going to use is blocks that we've already set up, and actually it's block singular, and then we can have our count. So we need to create a count first, so we can have public int count and set count equal to the length of our blocks array. And this way, since it's public, we'll be able to see while it's going on each block. But right now we have this in the start, and actually I want to continuously update this, so this should be in the update method, but this will be void you win, let's call it. So this is how you win. And so we'll update this in the you win, and we will just put you win in the update method, you win, and all of this, this is how the paddle moves. This will be pre-start game. So this will be before we start the game. So we can essentially just do cut and paste and do pre-start game. Now we have ours a little more organized. Now you win needs to happen if our count is down to 0, because we will constantly be checking the length of the array. So if the array ends up being 0, we can say that our you win or our end screen text will equal something. So end screen dot text equals, and we can say you win, and our end screen needs to have the ability to be seen, and so we need to create a UI text. And if you remember, that adds a huge canvas for us to use, and ignore our area here in the corner. This is what's going to be shown up on the screen. This is how our screen would display the text. So we want to center it, and we want to make it quite a bit larger, the size that we can do. And let's preview what you win would look like. We don't want it in black. We could have it a little bit bigger there. We want it in a color that we can really see. really be excited about. You win in yellow. Okay, now I'm going to actually get rid of it. And now in our game manager, we need to drag in the end screen text there. And then so when we run our game, we have our count at 42. And if count is less than or equal to 0, actually it's just equal to 0, but I'm not going to make you sit and watch me mess up this game. Let's check that our, whoops, so let's see our ball clone did keep going, so we need to make sure that we fix that. We fix our ball clone hitting the bottom, and let's change our count from equal to 0 to something a little bit easier. So let's just say that our count is less than 42, so we can check that. So less than 42. So then you save this. Okay, then you run it. And if you click, once you hit 1, you're down to 42. Okay, and you'll see the game manager count is 39, and it'll go if it gets 0. Now if we change it back to equals 0, then the UN screen will pop up. Okay, so now we want to make sure that our you lose screen also works. And so our you lose box does not have a box collider. 2D. And a rigid body 2D, and we will freeze it, but we will have it collide, and we will say, still in our ball, say if collision dot game object dot tag equals lose box, we will destroy this dot game object. Okay, save. Now we just check if we lose. It does get rid of, I see the ball disappears. And then let's go ahead and we can do something similar to you lose. From you win to you lose. So you can go you lose, and we can check let's say void you lose. We can say game object ball. Do we already have a ball in here? Yeah, we have initial ball here in our game manager. So we can say simply if our initial ball equals null, we can have our end screen dot text equal you lose. So we run it. You lose. Okay. There's no ball and no way to start the game. Okay, so now that you have simple brick breaker or breakout, you know, there's ways that you can add to it. Have a score counter, have blocks have multiple lives. Try out some new things and do something different. But I hope you guys enjoyed the video. Until next time, this is Coding Club signing off.